Hello everyone. I'm delighted to welcome you all to today's presentation on understanding hand movement capture in Oculus-3. I'm Dr. Che-Wei Lin, an associate professor here at National Cheng Kung University. This research represents a collaborative effort between several key departments at NCKU, specifically the Department of Biomedical Engineering, or BME, and the Medical Device Innovation Center, which we call MDIC. Today's presentation will explore the fascinating intersection of virtual reality and human-computer interaction, focusing on one of the most crucial aspects of VR technology, hand movement capture. The Oculus-3 system represents a significant advancement in this field, and we'll be diving deep into its technical innovations and practical applications. The image you see on the left symbolizes what we're striving for, the seamless integration of AI and human interaction in medical and engineering applications. That heartbeat line at the bottom isn't just decorative, it represents the vital connection between technology and human physiology that we'll be exploring today. Before we begin our technical discussion, I'd like to note that this research builds upon our lab's extensive work in wearable technology and mobile healthcare solutions. You can see our laboratory's focus represented by the header text, Wearable Technology and Mobile Healthcare Laboratory. Shall we begin our exploration of how Oculus-3 is revolutionizing hand movement capture in virtual reality? As you can see in this image, we have someone experiencing virtual reality firsthand, which perfectly sets the stage for our discussion today. The Oculus-3 represents much more than just another VR headset. It's a groundbreaking leap forward in how we interface with virtual environments, particularly through its sophisticated hand movement capture system. Our presentation today, exploring the intersection of VR technology and human interaction, will take you through several key areas where the Oculus-3 is making significant impacts. Think of it as a journey through three major domains. First, the gaming industry, where precise hand tracking is revolutionizing player immersion. Second, professional training, where accurate gesture recognition enables realistic simulation-based learning. And third, therapeutic applications, where this technology is opening new possibilities in rehabilitation and treatment. What makes the Oculus-3 truly remarkable is its technical sophistication. Throughout this presentation, we'll examine the intricate systems that allow for unprecedented levels of hand movement precision in virtual spaces. I encourage you to think beyond just the technology itself. Consider how these advancements are reshaping human-computer interaction and creating new possibilities across multiple fields. Let's explore together how this technology is transforming the way we interact with virtual worlds. Let me outline the structure of today's presentation, which will take us through four key areas of discussion. Starting with our introduction, we'll establish our objectives and set the context for understanding Oculus-3's role in the VR landscape. This foundation will be crucial for appreciating the technological advances we'll discuss later. Next, we'll explore the fascinating evolution of VR technology. We'll trace the journey from early virtual reality concepts right up to the sophisticated systems that led to the development of Oculus-3. This historical perspective helps us understand just how far the technology has come. The third section focuses on what I consider one of the most compelling aspects of VR, hand movement tracking. We'll examine why accurate hand tracking is absolutely essential for creating truly immersive virtual experiences. Finally, we'll culminate with a detailed look at Oculus-3's specific technological breakthroughs. This section will showcase how these innovations are pushing the boundaries of what's possible in virtual reality. Each of these segments builds upon the previous one, giving you a comprehensive understanding of both the technology and its significance in the field. Let's begin with our introduction. As we begin our detailed exploration of the Oculus-3, let's break down three fundamental aspects that make this device stand out in today's VR landscape. Looking at the Oculus-3 VR headset itself, we're dealing with more than just another virtual reality device. What sets it apart is its pioneering approach to hand movement capture. This isn't merely an incremental improvement, it's a complete rethinking of how users can interact with virtual environments. When we examine the technological leap, the advancements become even more impressive. The gap between Oculus-3 and its predecessors isn't just about better specifications, it represents a fundamental shift in how VR technology can interpret and respond to human movement. We'll explore specific features that demonstrate this evolutionary jump in capability. Regarding market position, the Oculus-3's impact on the VR industry is particularly noteworthy. As we analyze its place in the competitive landscape, you'll see how its innovations are reshaping user expectations and industry standards. The image above captures a user experiencing this technology firsthand, which perfectly illustrates the immersive nature we'll be discussing. Notice the natural interaction posture, suggesting how intuitive the system has become. Throughout this section, we'll delve into each of these aspects, showing how they collectively contribute to what I believe is a transformative moment in VR technology. Let's journey through the fascinating evolution of virtual reality technology, which I've divided into three crucial phases. The story begins with the origins of VR. While many view virtual reality as a recent innovation, its roots actually stretch back to early simulation devices. These pioneering attempts at creating artificial environments, though primitive by today's standards, laid the groundwork for everything that followed. Moving on to key milestones, we can trace a remarkable series of breakthroughs that shaped modern VR. Each significant development brought us closer to the sophisticated experience that Oculus-3 now delivers. Think of it as a technological relay race, with each innovation passing the baton to the next advancement. What's particularly interesting is how these various advancements have contributed to today's immersive capabilities. Each developmental step, whether it was improvements in display technology, motion tracking, or processing power, has added another layer to the rich, interactive experience we now take for granted. Understanding this evolutionary path is crucial because it helps us appreciate not just where VR technology is today, but also where it might head in the future. The journey from those early simulation devices to the Oculus-3 reveals patterns of innovation that continue to shape the field. Let's examine each of these phases in detail, starting with those earliest attempts at creating virtual worlds. Now let's focus on why hand movement tracking is absolutely crucial in virtual reality applications. The image on the right shows a user wearing a VR headset, but what really brings their experience to life is how they interact with the virtual world. Consider the immersive experience first. Our hands are our primary tools for interacting with the physical world, so it's natural that they should play the same role in virtual environments. When users can reach out and manipulate virtual objects just as they would real ones, the sense of presence becomes remarkably powerful. The versatile impact of this technology extends far beyond gaming. While gamers certainly benefit from intuitive hand controls, we're seeing transformative applications in medical rehabilitation, professional training, and numerous other fields. For instance, surgeons can practice complex procedures, while physical therapy patients can engage in targeted exercises that track their progress precisely. What's particularly fascinating is how hand tracking has evolved into a cornerstone of user engagement. Unlike traditional controllers, natural hand movements create an intuitive bridge between physical and virtual worlds. Users don't need to learn complex button combinations, they simply reach out and interact, just as they would in reality. The user in our image demonstrates the natural posture we aim for. There's no visible struggle with controls or interfaces. This seamless interaction is exactly what makes modern VR so compelling and effective across different applications. Let's dive into the technical aspects of hand tracking technology, breaking it down into three key components that make this remarkable system work. First, the foundational concepts. Think of hand tracking as a complex dance between sensors and software. At its core, we need to understand how VR systems perceive and interpret hand positions in three-dimensional space. The Oculus-3 implements these principles in particularly sophisticated ways, creating a seamless bridge between physical movement and virtual response. When we look at technology variants, we encounter a fascinating spectrum of approaches. From optical systems that use cameras to track hand positions, to inertial systems that measure acceleration and rotation, each method brings its own unique capabilities to the table. Picture it as having different tools in a toolbox, each perfectly suited for specific aspects of hand tracking. Now, let's consider the pros and cons of these technologies. No single approach is perfect, and understanding these trade-offs is crucial for both developers and users. For instance, optical tracking excels in precision but might struggle in certain lighting conditions, while inertial systems offer excellent response times but may need periodic recalibration. These three aspects work together to create the hand tracking experience you'll find in modern VR systems. As we proceed, we'll examine each of these elements in greater detail to understand how they contribute to the overall user experience. Let's position the Oculus-3 within the broader landscape of VR technology through three distinct perspectives. Looking at evolutionary development first, the Oculus-3 represents more than just another step forward. It stands as a culmination of years of hand tracking research and development. What's particularly fascinating is how it builds upon previous innovations while introducing entirely new capabilities that push the boundaries of what's possible in VR interaction. In terms of market competition, the Oculus-3 has carved out a unique position for itself. When we compare it with other VR systems currently available, several features stand out dramatically. The hand tracking precision, response time, and overall user experience set new benchmarks in the industry. We'll explore specific examples of how it outperforms its competitors in key areas. Perhaps most exciting are the unique innovations that Oculus-3 brings to the table. These aren't just incremental improvements, they're groundbreaking technologies that fundamentally change how users interact with virtual environments. From enhanced gesture recognition to more precise finger tracking, these innovations are reshaping user expectations of what's possible in VR. Understanding these three aspects helps us appreciate not just where Oculus-3 sits in the current market, but also its role in advancing the entire field of virtual reality technology. Let's examine the technical architecture that makes the Oculus-3's hand tracking capability so remarkable. We'll break this down into three interconnected components. Starting with hardware specifications, the Oculus-3's physical architecture represents a significant engineering achievement. The device incorporates cutting-edge processors and specialized components specifically designed for handling complex hand-tracking tasks. This hardware foundation is what enables the lightning-fast response times users experience. Moving to sensors and cameras, this is where things get particularly interesting. The Oculus-3 employs state-of-the-art optical sensors working in concert with high-resolution cameras. Think of it as giving the system multiple eyes that work together to create a complete, real-time picture of hand movements. The placement and interaction of these components are carefully calibrated to minimize latency while maximizing accuracy. The third component, software algorithms, is where the real magic happens. These sophisticated programs transform raw sensor data into smooth, natural hand movements in virtual space. The algorithms continuously process multiple data streams, predict hand positions, and adjust for potential tracking errors, all in milliseconds. What makes this system truly remarkable is how these three elements work in perfect synchronization. The hardware provides the raw power, the sensors capture the data, and the algorithms interpret it all into seamless virtual interaction. Let's explore the fascinating science behind hand tracking technology. The diagrams you see here illustrate two key aspects of this complex system. Looking at diagram A, we see a representation of the biomechanical principles at work. The joystick and headrest setup demonstrates how we study human hand movements in a controlled environment. This setup allows us to understand the natural range of motion and movement patterns that our tracking systems need to accommodate. In diagram B, we observe how these movements are translated into digital coordinates. Notice the target tracking system with its X and Y axes. This represents how we convert three-dimensional hand movements into precise digital information. The scientific principles underlying this technology are rooted in biomechanics. We must account for the complex articulation of human hands, 27 bones working in concert, each movement involving multiple joints and muscle groups. Understanding these mechanical relationships is crucial for accurate tracking. When it comes to VR tech integration, we take these scientific insights and transform them into practical applications. The challenge lies in maintaining precision while processing vast amounts of data in real time. It's a delicate balance between accuracy and speed. Too much delay breaks immersion, while imprecise tracking diminishes the user experience. What makes this particularly fascinating is how we've managed to recreate natural hand movements in virtual space with minimal latency. The system must predict and interpret movements almost instantaneously for a truly immersive experience. Now let's examine the hardware mechanics that make Oculus-3's hand tracking so precise. We'll focus on two critical components that work together to create this sophisticated system. The hardware setup is truly remarkable. Unlike previous generations, Oculus-3 employs a complex array of sensors strategically positioned to capture every subtle hand movement. Think of it as a network of digital eyes, each focused on different aspects of hand positioning. Each component has been carefully engineered and positioned to minimize tracking gaps and maximize accuracy. Particularly fascinating is the infrared LED system. This technology operates beyond the visible spectrum, projecting an invisible grid that maps your hand movements in real time. The brilliance of using infrared lies in its reliability. It works consistently across different lighting conditions and can detect even the smallest finger movements with remarkable precision. What makes this system truly special is how these two elements complement each other. The hardware provides the structural foundation, while the infrared system adds the layer of precise detection needed for nuanced tracking. Together, they create a tracking solution that can distinguish between the slightest variations in hand position and movement. This technological synergy represents a significant leap forward in VR interaction capabilities. Let's delve deeper into how each component contributes to this breakthrough in hand tracking accuracy. Moving on to the software side of hand tracking, we'll examine how Oculus-3 processes and interprets hand movements. The image on the left shows a gaming application, a perfect example of where precise hand tracking makes a crucial difference. Let's start with movement interpretation. The software employs sophisticated algorithms that transform raw sensor data into meaningful gestures. Imagine thousands of data points being processed every second, position coordinates, finger angles, palm orientation, all being analyzed in real time. The system needs to understand not just where your hand is, but what it's trying to do. The gesture differentiation capability is particularly impressive. Think about how many ways you can move your hand: pointing, grabbing, pinching, waving. The Oculus-3 can distinguish between these subtle variations with remarkable accuracy. What's fascinating is how the system learns to recognize the intent behind each movement, not just the movement itself. For example, in the gaming scenario shown here, the system must instantly differentiate between a quick wave and a swipe action, each potentially triggering different in-game responses. This level of nuanced recognition is what creates that seamless, natural feeling when interacting with virtual objects. The real breakthrough here is the speed and accuracy with which these interpretations happen, so fast that users experience no noticeable delay between their physical movement and the virtual response. Let's dive into the sophisticated software architecture that powers Oculus-3's hand tracking capabilities. This system consists of three interconnected elements that work together to deliver increasingly precise tracking performance. The software ecosystem forms the foundation of everything. Picture it as a digital nervous system, a complex network of programs working in harmony to process and respond to hand movements. This platform isn't static, it's designed to be flexible and expandable, allowing for continuous improvements in tracking accuracy. The integration of AI and machine learning represents a quantum leap in capability. These systems learn from millions of hand movements, constantly refining their understanding of human gestures. What's remarkable is how the AI adapts to different users, recognizing patterns in how individuals move and interact with virtual objects. Perhaps most exciting is the evolution through updates. Each software update brings new improvements, whether it's faster response times, more accurate finger tracking, or better gesture recognition. Think of it as a living system that grows more sophisticated over time. For instance, early versions might have struggled with quick movements, but through continuous refinement, the system now handles even rapid gestures with impressive precision. This combination of robust architecture, intelligent learning, and ongoing optimization creates a platform that keeps getting better at understanding and responding to human hand movements. Now I'd like to highlight a groundbreaking study that has significantly influenced how we approach hand tracking in modern VR systems. The research by Zhou and colleagues, published in 2020, represents a pivotal moment in hand tracking technology. Looking at the visualization before us, you can see a complex geometric representation of hand movement analysis. These colorful triangulated patterns demonstrate how a single camera system can capture and interpret hand shapes in three-dimensional space. What makes this research particularly remarkable is its monocular approach, using just one camera to achieve what previously required multiple sensors. This breakthrough has profound implications for VR technology. Traditional systems often relied on multiple cameras for accurate hand tracking, but Zhou's team demonstrated how sophisticated algorithms could extract the same level of detail from a single viewpoint. The impact on Oculus-3's development has been substantial. This research helped solve one of VR's most challenging problems: how to achieve precise hand tracking while keeping the system efficient and cost-effective. The geometric models you see in the image represent different hand poses being captured and processed in real time. The practical applications extend beyond just technical advancement. This approach has enabled more responsive and natural interactions in VR environments, whether for gaming, medical training, or professional applications. It's a perfect example of how theoretical research can lead to tangible improvements in user experience. Let's explore one of the most impactful applications of Oculus-3 technology, its role in medical rehabilitation. The image you see perfectly illustrates how VR is revolutionizing therapeutic practices. A fascinating study by MC1 and their team in 2023 demonstrates the remarkable potential of VR in rehabilitation settings. Notice how the patient in the image is able to engage with virtual environments while maintaining a comfortable, therapeutic position. This is crucial for effective treatment. What makes Oculus-3 particularly valuable in rehabilitation is its precise hand tracking capability. Therapists can now monitor patients' movements with unprecedented accuracy, allowing for detailed progress tracking and immediate feedback. The system effectively turns therapeutic exercises into engaging, interactive experiences. The impact on patient engagement is remarkable. Rather than repeating conventional exercises, patients interact with virtual environments that make therapy more engaging and less repetitive. This increased engagement often leads to better adherence to treatment protocols and, consequently, improved outcomes. The technology's sensitivity to subtle movements makes it especially valuable for tracking recovery milestones. Therapists can measure improvements in fine motor skills and range of motion with exceptional precision, allowing for more targeted and effective treatment plans. This represents a significant shift in rehabilitation practices. We're moving from traditional therapy methods to what we might call precision rehabilitation, where every movement can be tracked, analyzed, and used to optimize recovery strategies. Thank you all for your attention today. Before we wrap up, I'd like to emphasize several key takeaways from our discussion of Oculus-3's hand tracking technology. First, we've seen how VR technology has evolved from simple simulation to sophisticated real-time interaction. The Oculus-3 represents not just an improvement, but a fundamental leap forward in how we interact with virtual environments. Second, the integration of advanced hardware and intelligent software creates a synergy that makes hand tracking more natural and intuitive than ever before. This combination of infrared LED systems, sophisticated sensors, and AI-driven algorithms has opened new possibilities across multiple fields. Third, the practical applications extend far beyond gaming. From medical rehabilitation to professional training, Oculus-3's precision tracking is transforming how we approach complex tasks and therapeutic treatments. Fourth, the monocular tracking breakthrough we discussed shows how continued research and innovation can solve complex technical challenges while making VR more accessible and effective. Finally, as highlighted by our international audience symbols at the bottom, this technology truly represents a global advancement in human-computer interaction, bringing together expertise and applications from around the world. Looking ahead, we can expect even more exciting developments as this technology continues to evolve and find new applications in various fields. I welcome any questions you might have, and thank you for being such an engaged audience today.